Okay, we're going to find the derivative of this function without simplifying. So this one is using the chain rule. And how we can see that is because normally, right, we would have this nice lovely function, something like, I don't know, f of x, and that is equal to x to the power of minus 2. So when you differentiate it, you bring that 2 down the bottom, and you minus 1. Okay? And so really that would be equal to minus 3. Okay, but now instead of just having x here, we've got this whole other complicated beast. But what you need to see is it's like a function inside a function. So the chain rule. And there's two ways of doing this. I really like this method. I think it's easier in the long run to understand. This one is more formal, and they might get you to do it. So I'll explain that in a bit. So the first step is this one here. All right. We got to have a look to see what function is on the outside. We've given it a name. We're going to call it f of x, right? Except this time we're not going to put in just x there. We're going to put in this function g of x. And for us, we know that this function is looking like this. Okay, so now we're going to pick that up and put it into what we've already done, this outside function here. Okay, so then we get f prime with the g of x in it. And that is equal to exactly what we had before, except now, as you can see with that little red circle, we're going to put this guy. And so what we get is this. So this is pretty much half the work done. Okay. The next step is that we now need to multiply the function by this guy's derivative. Okay. So hopefully what you can see here is that this represents this bit, and what we're about to find will represent this bit. Okay, so let's do it. We need to find g prime of x, and that's equal to minus 3. Bring down that 3 and minus 1 from it. Okay, so that'll be 2 at the top. And then when we have a constant, that's like saying, I don't know, minus 8x to the power of 0. Because to the power of 0 is an interesting thing, right? If I've got 8, well, let's do a different number. 10 to the power of 0. Punch it in your calculator, you get that's equal to 1. So that is just like saying minus 8. But now when you differentiate it, you grab that 0 and you put it down and you get times by 0. And so anything times by 0 is 0. So this whole thing is going to be 0. Another way to think about it is if you have your graph and you're plotting, or in this case, minus 8, right? So y is equal to minus 8. What is the gradient? Like if I was to put a ball on this thing, would it roll left, indicating a negative gradient? Oh, sorry, indicating a positive gradient, because this is a positive. This is a negative, which would indicate that it would roll to the right. Or if it's flat like it is now, the gradient is 0. So all of that just to say that this guy here is equal to 0. And then the last bit we can do quite quickly. 6 minus 1 is 5. And then just to make that look a bit nicer for me, okay? And now all we do, right, is we grab that purple bit and we multiply it so that we get this bit over here. Okay, so let's do that. We will get g prime of x, which is all of this stuff we've just done. And then we say times that by minus 2 and bring in the rest of it. So again, this bit, and we've got this bit. There we go. The next step that we can do to solving all of this is to do a formal definition where we're gonna kind of use. So yeah, we've solved this thing, by the way, but we're just going to be using like a more formal definition to go through this dy du thing. So what we're going to say is the guts of it, right, is we like this bit in here, and we can say that's all equal to u. Okay, so then we can have, q in terms of u, right? So we substitute it out, literally pick up all of this and put a u in instead. And that would be u minus 2. So you can see the similarity from further up when we were doing this one here. So it's the exact same thing. And we differentiate u. So dq du is equal to, as we've gone through. But now we want things in terms of x. So we want dq dx. All right. So one way we can do that is to get u over here and differentiate it with respect to x. So we can write du dx. And that is equal to doing the same steps as above. Okay, so now we do the same thing. They just need to multiply each other. So dq dx is equal to dq du times by du dx. Okay, so now you can see, hopefully, where they come into it. Okay, so if we multiply everything out, we're almost there. And now the problem is that we've still got this pesky u here. So we need to substitute it out using this equation at the top here. That's our last step, and then we've completed the question. So normally you'd recommend writing things to say substitute. So sub u equals, and then all of that. Into equation, just to let the marker know what you're doing. But those are the two methods. Now, the question will be automatically generated. So hit F5 or scroll down to the bottom of the page and say generate a similar question. and practice. You've got to practice, otherwise watching this video won't be enough to get you good marks in the exam.